Thank you, Dr. Mark Hirsch, for this beautiful introduction. Also, special thanks to the extraordinary women that will compose our panel. Huge thanks to the ACRM for this marvelous opportunity. Ladies and gentlemen, welcome to the 5th Annual Women in Rehabilitation Science Special Symposium. If you really want to change the current scenario in science, teach young girls that they can be scientists and make discoveries. This is the outline of my talk: Gender Inequality in STEM, Inequalities in Science and Rehabilitation, Structural Barriers to Career Progression, Mentorship and Career Planning, finally, my contribution to rehabilitation medicine. Let's use my case as an example. I'm a cognitive neuroscientist from ethnic, geographic, and socioeconomic underrepresented backgrounds. In my trajectory, I complete a PhD at Federal University of São Paulo. I did a PhD exchange in Durham University in UK. I returned to Brazil as an assistant professor at São Paulo State University, and I worked there for 9 years. Then I started my career abroad in Europe as a researcher at University of Murcia in Spain. I complete 5 years of a postdoctoral research in Portugal, and then I returned to Spain at University of Murcia as a lecturer. And in 2018, I was contracted by the University College Dublin as an assistant professor and Ad Astra fellow. In this period, I managed to publish 60 articles, 6 books, and according to the Web of Science, I have an average citation per year of 18.7 articles. In terms of funding, I achieved 14 grants, which represents around 744,000 euros, including 6 multi-site studies. My grants come from Brazil, Spain, Portugal, France, and Ireland. Now I ask you, do you believe in meritocracy? You might wonder, why should we focus on academia if there are plenty of clinicians, especially at the ACRM? The reason is that academics will form most professionals, and students will learn from and reproduce their stereotypes. Diversity became a hot topic in 2020 after some tragic events. We all know that it is related to age, gender, sexual orientation, disability, race, ethnicity, and culture. However, I must highlight that diversity includes more elements such as geography, socioeconomic status, area of expertise, level of experience, among others. So when we talk about diversity in science, we hope to see individuals from the entire social spectrum, which means those from traditionally well-represented areas, also individuals from underrepresented backgrounds. Note that the term diversity is not a unique or isolated item from this list. Diversity is always a combination of those categories, which creates unique individuals. Therefore, when we talk about diversity, we must include the term intersectionality, because those categories, they are overlapping, they are interconnected, and more importantly, they are directly related to all inequities we see in the societies. This is an iconic picture, very important in 1927 when it was taken at the International Conference on Electrons and Photons, and very important nowadays for many reasons. We can see influential researchers such as Einstein, Schrödinger, Heisenberg, Planck, and the only female in this group is Marie Sklodowska-Curie. At that time, science was dominated by white, heterosexual, able-bodied, Anglo, middle-class males. Marie Curie's achievements were important to show that women belong to science. Women can do discoveries and achieve excellency. Despite this iconic contribution by Marie Curie and other women from her time, in 2021, we still need articles like this one from Sarah Hughes discussing the permanent contract. I'm sure all of you have heard a case of a PhD student who heard from the supervisor, hey, you shouldn't have a boyfriend, or you shouldn't get married, or a postdoctoral who heard from the PI, listen, if you get pregnant right now, you won't be able to do this international exchange. So we see like as natural to force women to wait for a permanent contract to define their personal lives. And this is creating both a metaphorical and a biological infertility, because if you are not fulfilled as a human being, how can you be really productive? And then again, if you are waiting too much to start your family, it might be biologically late. You are probably asking yourself, are science career and maternity incompatible matters? The truth is, nearly half of US female scientists leave full-time science after first child. In the left side, you see a graphic with a bar for mothers and another bar for fathers, divided in 4 categories. Individuals who stayed full-time in STEM, individuals who moved to part-time in STEM, individuals who moved to a non-STEM career, and those who left workforce entirely. In all categories, we see that mothers left their posts more often than fathers. It means that we don't have worldwide an effective system to support women in the first years of motherhood. And in this other study, we also could see how the pandemic could impact academics' career worldwide. So in this study, we have almost 20,000 academics who answered a few questions. And we can see clearly that for all of us, there was a reduction on time dedicated to research and an increase of time dedicated to childcare and housework. However, if you pay attention to the bars, you'll see that the black bars representing female, they indicate that women lost more hours per day for research and spend more hours per day in childcare and housework. So we can see clearly that is still this imbalance. Now, let's understand career patterns. In this study by Gibbs and colleagues, they interviewed people who just completed their PhDs in biomedical or behavioral sciences. And they included 4 groups, let's say, well-represented male, well-represented female, underrepresented male, and underrepresented female. And they also categorized 4 possible pathways. 1, research intensive, 2, teaching intensive, 3, research but non-academic, for instance, a clinician or someone in industry, and 4, non-research career. When we're looking at the graphics number 2 and number 3, we see the 4 groups plotted in there, and we see that there's no difference between them in terms of likelihood to achieve a pathway in teaching intensive or in research non-academic. So there is equality in those categories. However, when we're looking at other possibilities like the number 1, research intensive, it's just like seeing that picture of Marie Curie and her colleagues at the conference, where you can see clearly that only male from well-represented groups, the circle in blue, have a higher likelihood to become a research-intensive professional. And then when you're looking into the number 4, which is the opposite pattern, we see that only female from underrepresented backgrounds have a higher likelihood to achieve a career in non-research pathway. So let's understand what happens when a person just finished the PhD. So in the past, usually you would get a postdoctoral, which would be an experience that you achieve, let's say, in a huge top center, and right after obtaining those skills, you would start your own lab and thrive in your career. Nowadays, postdoctoral become actually a name of a new job, and unfortunately is a fixed term job where you stay 2 years in one institution, then another 2 years or 3 years in a different institution, and you are always just supporting the work of others. You are not building on your own career. So in this study, they interviewed more than 7,000 postdoctoral researchers, which were based in 93 different countries, and they had several questions. I select just a few ones. For instance, is there a long hours culture at your university? 47% replied yes. In fact, when we're looking at how many hours they were working beyond the time they were contracted, we can see that about almost 30% were working between 6 and 10 hours more than the contracted. But we also can see people working even 20 hours more. Then in the same study, they asked the level of satisfaction in the previous year. And I want you to looking at the first top bars. Let's say the first one says significantly worsened, and the second says worsened a little. If you sum up the results of those percentages together, they represent 50% of the responses. So it's clear that satisfaction is not exactly the main response we could expect from those individuals. In fact, fewer than half would recommend a science career to their younger self. But imagine the case of those who actually succeed, or let's say survived, this postdoctoral period and become assistant professors. So in this study, almost 3,000 individuals were followed up were workers in science and engineering. So they were from physics, engineering, chemistry, mathematics, biology, computer science, etc. And the results were really striking because the median time to exit the tenure track career was about 10.9 years. So stop and think about it. Imagine that you invested 10 years of your life and suddenly you just leave because you realize that it's not a good pathway for you. In most of those areas, we don't see any difference between men and women, but specifically in mathematics, this was the only field where they left earlier and men left slightly later than women. Just to not be so pessimistic, for those who actually had a positive outcome, 64% were promoted at the same institution. So let's start to understand why it's so difficult to remain in academia. First of all, you need funding, because without funding, you don't complete research, and without doing research, you don't publish, and without publishing, you don't get the impact factor your university is expecting from you. So here I give you an example, one publication from 2011. It is published on Science, and in this study they had 83,000 participants, and they were stratified according to the race or ethnicity. So in blue you see Black or African American, and as you can see they have about 16% of probability to receive an award from the NIH. In comparison to the other groups, Asian, Hispanic, and white, all of them have higher than 25% of chance to get the grant. And if you don't understand what we are talking about when we say structural barriers, we are saying to you that what happened in the past is still dictating what is happening right now. So if, for instance, if you're looking at this new study from 2018, you find out that the pattern is still the same. Let's say the only thing is that here they are showing new applicants separated from experienced applicants. And again, when you're looking at the different racial and ethnic groups, we will find out that in this case, in the color red, you see that the Black individuals, they have lower probability to receive an NIH grant. This is not just a question of race and ethnicity. When we include gender in this equation, we see a very clear pattern. So in this study, Ginter and colleagues, they had data from 87,000 applicants for NIH grants. And what they see is, on the top, you see two graphics, one representing PhDs and other master degrees. So in the top, you see the applicants for grants by gender and ethnicity. And we see that Black women had lower probability to be an applicant. And then, more importantly, when you're looking at the bottom graphics, you see the probability of receiving an award. And again, Black women had lower probability to receive a grant. Another reason to abandon academia is the experience of harassment. So a few foundations are nowadays trying to collect information about this issue. And I'm using here the example of the NIH. So after some pressure, NIH collected data between 2018 and 2021 and obtained 314 complaints. Those complaints were related to sexual harassment, other harassment, bullying, and racial discrimination. And once they detected, they informed the universities, which were supposed to do investigation and deliberations. And after that, 75 lab heads were removed from their NIH grants by their institutions. Now, after surviving pregnancy, harassment, and postdoctoral posts and being an assistant professor, the pathway should be clean, right? You just get a promotion and you can become an associated professor, a full professor, or a department chair. Do you think it's really equal for men and women? Well, this fantastic study with 559,000 graduates from US medical schools show us clearly that's not the case. So individuals which graduate between 1979 and 2011, they are all together in those graphics. And we see in the middle the dashed line with the zero, representing the separation between what is in favor of women on top, what's in favor of men on the bottom. As you can see, the dots, all of them are below the zero line. So it means that in all the cases, with the exception of those as I'm circulating right now, all were in favor of men. And while presenting in a conference of physical medicine and rehabilitation, I could not leave you without details about this field. And if you're looking at the graphics on the right side, where we can see academic leadership and training program, you will see that the pattern observed in those graphics is the same as discussed in the previous article, where we can see that the percentage of men here in blue is higher than the percentage of women here in red in top posts like professor, chair, program director, medical director. However, what I really would like to highlight here is the case of the prizes, because prizes are also elements that we can use to request a promotion. And what we can see is that in rehabilitation medicine, there is a prevalence of men receiving prizes in comparison to women. In some specific prizes, it's 100% of the cases. So the gender disparity is really strong in this field. Let's talk about physician compensation. So here we have all the salaries. This is a survey published in 2019 by the Medscape with 19,000 respondents, more than 19,000 respondents. And we can see that the physical medicine and rehabilitation salary is not the highest, but it's also not the lowest, so it's in the middle. But what I really want you to see here is that clearly women receive lower salaries than men when they are in the primary care physicians or when they are in specialties. And surprisingly, women work more hours in paperwork and administration in comparison to men physicians. So definitely we see something very strange and ongoing here. And also, when we're looking at the ethnicity, we see the usual pattern where you see Caucasian and white receiving more than all the other groups, but in particular, the African American individuals, they have lower salaries in comparison to the other physicians. Concerning disabilities, not all forms of disabilities are visible, and among the medical community, we know that medical students rarely disclose their disabilities, and when they become physicians, the pattern remains. So very few individuals will report their disabilities. And in terms of employment, we can see that individuals with a disability now stratified by gender and ethnicity and race, we can see that men and individuals from underrepresented minorities are the ones with higher percentages of employment once they become scientists. However, pay attention to the left axis, which represents the percentage of employment, and you can see that we are from between 0 and 12. Which means that very few individuals in those categories are receiving job opportunities. Another reason to consider intersectionalities is related to lesbian, gay, bisexual, transgender, and queer individuals and professionals in STEM. So according to this interesting study, unfortunately, individuals from LGBTQ groups, they have less career opportunities, less sufficient resources, less comfort for whistleblowing, and by contrast, they have higher professional devaluation scale, higher percent of experienced harassment, and higher social exclusion. So this is really important. After providing some examples of intersectionality, I think it's useful to give you some theoretical framework to understand this process. And the main idea is discussed by Duprat and Eyrick, which says that cumulative advantages is a mechanism for inequality. So if you're looking, I don't have the time to explain the entire theory, but if you read the second line, we'll see what is the main idea here. So small advantages or small disadvantages at an early stage of a process grow larger over time. So imagine if you are looking at those images, it's a very good example of how the lack of resources could be detrimental for the development of a student. In the same way, if an undergraduate student is living near to the university or even on campus, if the student will have a grant, all those benefits will make the trajectory easier and more successful across the time. Now we have the opportunity to think about solutions. So how do we change this scenario? We have a few examples of successful strategies. One of the cases is this advanced grant, which is funded by the NSF. Researchers who receive this grant, they create the strategic toolkit, and strategic is an acronym for strategies for affecting gender equity and institutional change. So this is one example. But in the current year, in the current year, the OECD just released this policy paper about reducing the precarity of academic researcher careers. So they show us 9 steps that we could follow to ensure that we make easier and smoother the process, the transition from the PhD to post in science. In specific countries or areas of the globe, continents, we have specific initiatives. So I'll just give you 2 examples. One is the MSCA, or Marie Slaughter-Curie Actions, which is a combination of several grants which allow professionals from different fields to have postdoctoral experiences, especially international experiences, and build their own labs rather than just work for others. The other example I would like to cite is the UNITE initiative. UNITE is also an acronym which represents different committees organized by the NIH, and they are aiming to end the structural racism. However, I must say to you, it's not just about money. Of course, science needs grants. It's crucial for keep going on research. However, if you are in an environment that's not welcoming you, you will not thrive. So we need to change the academic climate. And for changing it, we need intervention for men. Yes, to help men to change their minds, to make them aware of those disparities, and to help them to intervene properly in cases of misconduct. And also we need intervention for women, because we have problems for recruiting, for retaining, and for promoting faculty researchers in this area. Mentoring programs can help to change the scenario, and they should be tailored for women and also for underrepresented minorities, because of course those are the outnumbered individuals in the institutions. So it will help to increase the retention of faculty and students from these backgrounds, also to diversify the pipeline of bachelor's degrees and graduate students, but more importantly, it will start to change the scenario by preparing those individuals to lead, which is something that rarely happens in the current state. One excellent example of a program that could help women to become a leader is the Career Advancement and Leadership Skills for Women in Healthcare, developed by the Harvard Medical School. And the course director is Julie Silver, which is the ACRM Excellence in Cancer Rehabilitation Award from 2019. So now we cannot just expect solutions from the institutions, the universities, the societies, and the governments. We should take action as individuals. So my suggestion is become a volunteer, try to learn more about this topic. Maybe next year you should be the speaker of this seminar. Build a team in your institution, ensure that other colleagues are speaking the same way with the same ideas as you, make these ideas stronger, and celebrate the triumphs of individuals from underrepresented groups, like invite them for giving talks, not just about intersectionality or diversity, but about their own work. Invite them to be co-authors, to be researchers with you. You can also be a mentor for those individuals. They need support, and you might have the experience they would like to hear about. And finally, and perhaps the most important, remember that we are all human beings. We all have biases, so check your biases. Like I said at the beginning of my talk, open kids' minds. I would like to highlight this beautiful work by Dr. Thian Griff, which is a neuroscientist from University of California, Davis. She's writing books for children to inspire them to become scientists. And All the books are illustrated by Reggie Brown and including individuals from underrepresented groups, including children with disabilities. So now I would like to show you my contribution for the retention of women in STEM. We know that during the childhood, low numeracy is something quite frequent. We know children that have difficulties to learn mathematics, that have low grades in mathematics, and it causes low self-esteem, low motivation. Some children will abandon school quite early and will get low grades, which will not lead them to the university. So usually we think about the consequences of low numeracy just on childhood. But today I'm going to show you that academic failure, particularly in mathematics, will have a long-lasting negative impact for the individual and society. It undermines economic, social, and psychological outcomes in adulthood. For instance, longitudinal studies observed that individuals with low numeracy, they obtained higher risk for depression, more trouble with authority, lower occupational status, and lower incomes. In terms of economy, the annual cost of low numeracy to the UK economy is higher than £7 billion. There are several causes for low numeracy during childhood, from intrinsic causes, for instance, a learning disability, to extrinsic ones, such as cultural and environmental factors. One factor that impacts mathematics learning and mathematics performance is mathematics anxiety. A child with mathematics anxiety may have difficulties to sleep the night before a class or an exam, may arrive at school sweating, shaking, and afraid of looking at the teacher. While doing exercises, the child might forget all that was studied in the entire week. In this study by Devine and colleagues, they were examining mathematics anxiety using a scale and also mathematics performance. The results we can see in the graphic, in red girls and in blue boys, that girls had higher mathematics anxiety and boys had lower mathematics anxiety. However, they performed equally, which means that both are capable of learning mathematics. Also, it means that girls are competent but not confident regarding mathematics. You could think that this is an issue that happens only during childhood, let's say third grade, fourth grade, and then it's over. However, the research proves us that it's not the case. In this study, researchers did a follow-up with undergraduate students. They were examined in mathematics anxiety in the first year of their courses, and they observed that the presence of mathematics anxiety was uniquely accounting for a reduction on the STEM course that students were choosing, which means that they were avoiding STEM area if they had mathematics anxiety. Also, those students, they underperformed in those modules if they had mathematics anxiety. But more importantly, those results were independent of mathematics ability. So I just got funded for carry out this study at the Arithmos project. Arithmos means numbers, and transforming children's mathematics education through digital games. So in this study, we will augment 2 digital educational games with adaptive features specially designed to address mathematics anxiety. So we hope that by using those games, we will have better mathematics performance and lower mathematics anxiety. And for doing it, of course, we do an RCT study with several controlled conditions and with a large sample. And we hope to obtain a better interface between teachers and students, better grades, and as scientists, we are interested in the sustainable developmental goals, so we hope to target all of them here. Apart from my research in neurodevelopmental disorders, I would like to introduce you to my contributions for aging research. So in 2016, I was the only South American representative at the International Summit on Intellectual Disability and Dementia. And as outcomes of this important summit, several articles were published. Also, I'm a member of the IACD, the International Association for the Scientific Study of Intellectual and Developmental Disabilities. These are the books I edited during the pandemic. Regarding my research line, I have two main interests. One is screening tools for neurocognitive disorders, including tools for the general population and also for individuals with intellectual disabilities. The second research line is about healthy aging. For instance, longitudinal effects of physical activity on cognition of older women, and aging interventions for people with intellectual and developmental disabilities. I'm a member of the ACRM family, including two networking groups, the NDNG, Neurodegenerative Diseases, and ARGR, Aging Research and Geriatric Rehabilitation. We are carrying out information education pages, white papers, systematic reviews, and currently we have a research topic at Frontiers in Aging Neuroscience. So if you have a research in post-acute sequelae of COVID-19 infection targeting older adults and neurological care, please submit your work to our research topic. I hope this talk gave you food for thought, and now I leave you with this wonderful panel composed by Dr. Patricia Hine, Dr. Kelly Gary, Dr. Monique Papadis, Dr. Alison Coogan, Dr. Deborah Bacchus, and Dr. Mark Hirsch. Ladies and gentlemen, thank you so much for attending the 5th Annual Women in Rehabilitation Science Special Symposium. I'm delighted to answer any questions you may have. Please join our panel in this amazing discussion and enjoy the entire conference. Thank you for your precious time. Thank you for being here today.